I'm Daze Thomas, Assistant Professor, Department of Artificial Intelligence and Data Science, SNS College of Engineering. Today, let us discuss about processes. In an operating system, process concept is very important. An operating system executes a variety of programs that run as a process. A process is a program in execution. Process execution must progress in a sequential fashion. No parallel execution of instructions of a single process can happen. The different parts of a process are: first one is text section, which contains the program code. Second one is the program counter, the current activity including program counter, processor registers. Next one is stack, which contains the temporary data like function parameters, return addresses, local variables, etc. Next one is data section, which contains all global variables. And another one is heap, which contains memory dynamically allocated during runtime. So these are the different parts of a process. Program is a passive entity stored on disk, while process is an active entity. Program becomes process when an executable file is loaded into memory. Execution of program started via mouse clicks, command line entry of its name, etc. One program can be several processes. So let us consider multiple users executing the same program. For a process in memory, this is the structure of a process. You have text, data, heap, and stack. In this image, you can see the memory layout of a C program. You have a diagram given here which contains text, initialized data, uninitialized data, heap, stack from low memory to high memory. Next, we have different process states. The different process states are new state, running state, waiting state, ready state, and terminated state. When a process is being created, then the process is in new state. Instructions are being executed, then it is in running state. A process is waiting for some event to occur or any IO request is there, then it will go to waiting state. Process is waiting to be assigned to a processor, then it is in ready state. If the process has finished execution, then it moves to terminated state. So these are the various states of a process. Next, you can see the diagram of a process state. In this, first initially the process will be in ready state and it will be admitted to ready state. Okay. After that, when the scheduler dispatch is happening, it moves to the running state. In running state, if it is executed, completed executed, then it moves to terminated state. Or if any interrupt occurs, it moves to ready state again. Or if there is any IO request or any event wait is there, it moves to waiting state, and from waiting state after the IO completion or event completion it moves to ready state, and from there it moves to running state and then gets terminated. This is how a process works using a process state diagram. And every process has a process control block which has different parts. First one is process state. You can mention the state of the process, either it is in running, waiting, ready, terminated, whichever it is, you have to mention. Next one is program counter. It has the location of instruction to the next executed instruction. CPU registers contents of all process centric registers. Then CPU scheduling information has all priority scheduling queue pointers, etc. Memory management information contains memory allocated to the process. Accounting information contains CPU used, clock time elapsed since start, time limits, all these. And last one is IO status information, which contains all IO devices allocated to the process, list of open files. So in today's class, we learned about process concept, different states of a process, different parts of a process. Then we saw process state diagram and process control block. Hope you are all very clear with the topics. Thank you.